In this question, we were given the information that a local school is planning to construct a new sports ground in the shape of a rectangle with semicircular ends. A running track, which is 440 yards long, is to go around the perimeter. So as you can see, we have a rectangle, semicircular ends, and we're going to have a perimeter of 440 yards. We need to determine the dimensions that will make the rectangular area in the middle a maximum. On the right, for each row, we need to choose the statement that best completes the sequence of statements leading to the equation to determine the maximum area of the rectangle. Let's get started. The first thing that we need to do is come up with an equation for the perimeter. In this case, the perimeter is equal to 2x plus 2 pi r. The 2x's represent the distance going across the top and bottom, and the 2 pi r represents the circumference of a circle. Notice that we have half a circle on the left and then half a circle on the right. In addition, we also know what the perimeter is. We know that the perimeter is equal to 440 meters. Next thing we need to do is isolate for one of our variables. The variable we'll choose to isolate for here is x. In order to isolate for x, we'll need to subtract 2 pi r from both sides of the equation. When we do that, we're left with 2x is equal to 440 minus 2 pi r. Next, in order to get x by itself, we need to divide everything by 2. And so we're left with x is equal to 220 minus pi r. Next, we need to come up with an equation for the area. In this case, the area is equal to 2xr. The x represents the distance going across the top of our rectangle, and if you look at the width would be r times 2, because r is the radius, so we'd have to double it to have that entire width. So we get area is equal to 2xr. Now, we can take the equation that we have above here, x is equal to 220 minus pi r, and it will get substituted in for this x. When we do that, we have the following: 2r, all multiplied by 220 minus pi r. Now, distributing the 2r across the 220 minus pi r gives us 440r minus 2 pi r squared. The next thing we'll do is put it in descending order of powers, such that we have the r squared going before the r. From here, we're now ready to go ahead and complete our square. First thing we would need to do is factor out the leading coefficient. Normally that might just be the negative 2, but because we have a pi, we also have to factor that out. So we factor out a negative 2 pi, and we're left with negative 2 pi, and then brackets r squared minus 220r over pi. Now we'll take this term, we'll divide it in half, and then square it. And we'll add that number, which is 12,100 over pi squared, minus 12,100 over pi squared. The last term right here needs to get multiplied by our leading coefficient, negative 2 pi, to bring it outside of our brackets. When we do so, we're left with 24,200 all over pi, and so this will be our maximum area of that rectangle. And then finally, to figure out what the dimension would be, we now need to go and complete our square right here. When we complete the square, we're left with r minus 110 all over pi. So the dimension of our radius would end up being 110 over pi. And this number right here would be our area. Finally, we can see the entire equation to maximize the area would be area is equal to negative 2 pi, all multiplied by r minus 110 over pi, all squared, plus 24,200 over pi. Finally, let's check our solution, and we are correct.